Alright, here we are with Lesson 16, Population Problems. And we should have done the first part in class, and hopefully you were present for this. So, the in-class exercise, you should have a table filled out from our discussion in class. If not, you will need to skip ahead from this exercise and make it up at another time. But if you were part of the in-class exercise, then go ahead and finish calculating the percents for the questions in the table. Alright, once you've done that, next we are going to discuss questions based on the table. So that's why you need to have your table filled out so that you can participate in the discussion questions. So, based on your table, how did you calculate the percent of boys in class? How did you calculate the percent of girls in the class? Well, you take the number of each gender group, divide by the total number of students in the class, and then multiply by 100%. So what is the difference between the percent of girls whose names begin with a vowel and the percent of students who are girls whose names begin with a vowel? Well, the first is the number of girls whose names begin with a vowel divided by the total number of girls, as opposed to the number of girls whose names begin with a vowel divided by the total number of students. So is there a relationship between the two? Well, yes. If you multiply the percent of students who are girls and the percent of girls whose names begin with a vowel, it equals the percent of students who are girls and whose names begin with a vowel. So if the percent of boys whose names start with a vowel and the percent of girls whose names start with a vowel were given, and you were to find out the percent of all the students whose names start with a vowel, what other information would be necessary? Well, you would need to know the percent of the total number of students that are boys or the percent of the total number of students that are girls. Alright, so now you should be at example 1, and if you weren't part of the in-class exercise, then this is where you would start your lesson. So a school has 60% girls and 40% boys. If 20% of the girls wear glasses and 40% of the boys wear glasses, what percent of all students wear glasses? So we're going to let n represent the number of students in the school, because we don't know what that is. So the number of girls is 6/10 times n. Remember, that is 60%, which is converted into a usable form, which is a decimal. You could have also used a fraction too, but we're going to use decimals throughout this lesson. So 6/10 n, the number of boys would then be represented by 4/10 times n. And we are going to be utilizing very heavily tape diagrams, so please stop and sketch this out and practice using these throughout this lesson. So, in a tape diagram, 100% of the students, 60% of the girls would be 0.6 times n, and 40% of the boys would be 0.4 times n. So, the number of girls wearing glasses is as follows. If it's 20% of the 60%, then that would be 2/10 times 6/10, which would give us 12/100 times n. And the number of boys wearing glasses would be 40% of 40%, so 4/10 times 4/10, which is 16/100 times n. So showing that again, our original tape drawing, we would have to take our tape section of 60%, split that up into common or equal areas of 20% so that we could show 20% of 60%. And the same thing with the boys, taking the section which is 40%, we would have to split that up into sections where we could get 40. So that would be taking 40% and split it up into 5. Well, 40 divided by 5 is 8, so this would be 2 sections of 8, which is what gives us 16/100. So the total number of students wearing glasses is 12 hundredths n plus 16 hundredths n, which would equal 28 hundredths n. So 28 hundredths is 28%, so 28% of the students wear glasses. And that is 28% of the whole student population. Can you explain the reasonableness of the answer? Well, yes, if we assume that there's 100 students, then 20% of 60 girls is 12 girls, and 40% of 40 boys is 16 boys. The number of students who wear glasses would be 28 out of 100, or 28%. So here is what we would have. If this is 100% of the student population, then this would be about 28% of that student population. Again, we don't need to know what the population is, but we can figure out what percent of whatever population is going to probably be wearing glasses. All right, so try these problems using the information from example 1. Continue the video to check your answers. Okay, you should be done with example or exercise 1. So again, pause the video and check your work. Again, don't forget to use the tape diagrams. Make sure you sketch those out if you didn't originally try to fit those into the problem. All right, if you're done with exercise 1, here is exercise 2. All right, so now if you have any questions on either of those, make a note and bring them to class. So explain why the expressions 12 hundredths times n plus 16 hundredths times n and 28 hundredths times n are equivalent. Also explain how they reveal different information about the situation. Well, the equivalence can be shown using the distributive property. 12 hundredths times n represents the fact that 12% of the total are girls that wear glasses, and 16 hundredths n represent the fact that 16% of the total are boys that wear glasses. So 28 hundredths times n represents the fact that 28% of the total student population wear glasses. All right, let's take a look at example 2. So the weight of the first 3 containers is 12% more than the second, and the third container is 20% lighter than the second. By what percent is the first container heavier than the third container? Well, again, we're going to let n represent the weight of the second container, and it doesn't have to be n, it could be x or whatever you want to use. But it has to represent the second container. The tape diagram representation for the second container is divided into 5 equal parts to show 20%. This will be useful when drawing a representation for the third container, and also when sketching a 12% portion of the first container, since it will be slightly bigger than half of the 20% portion created. So here is our tape diagram. We're going to split the 100% of the second container into 5 equal parts, each representing 20%. So the weight of the first container is 1 and 12 hundredths times n, because remember it said it is 12% more. So this would be 100% plus 12%, so that would be 1 and 12 hundredths times n. Now the weight of the third container is 80% or 80 hundredths times n. So that means we would take off the 20% of n, which means that it is 80% of this second container. So the following represents the difference in the weight between the first and third container. 1 and 12 hundredths n minus 80% n, or 80 hundredths times n, equals 32 hundredths n. So recall that the weight of the third container was 80% of the second, so that would be 8/10 times n. So now we would divide it. 32n divided by 8/10 n is 4/10. So the first container is 40% heavier than the third container. Or you could say 1/4, or 1 4/10 times 100% is 140%, which also shows that the first container is 40% heavier than the third container. So how can we represent the weight of the third container using another expression besides 8/10 n? Well, you could say n minus 20 times n. Compare these two expressions and what they tell us. Well, n minus 20 n tells us that the third container is 20% less than the second container, while 8/10 n shows us that the third container is 80% of the second container, and both are equivalent. So after rereading the problem, can you explain the reasonableness of the answer? So if the second container weighed 100 pounds, then the first container weighs 112 pounds, and the third container would weigh 80 pounds. So 112 divided by 80 is 1.4, 1 4/10. So the first container is 40% more than the third container. So what is the importance of the second container? Well, it is a point of reference for both the first and third containers, and both expressions are written in terms of the second container. All right, so let's take a look at exercise 3. Complete it and continue the video to check your answer. All right, you should have something to this effect for exercise 3. That Matthew's dog is 33 7/75% heavier than Janice's dog. All right, let's take a look at example 3. In 1 year's time, 20% of Mrs. McElroy's investments increased by 5%, 30% of her investments decreased by 5%, and 50% of her investments increased by 3%. By what percent did the total of her investments increase? So let n represent the dollar amount of Miss McElroy's investments before the changes occurred during the year. So n is her original investment, and we've split it. Since we're talking about factors of 10% here, we're going to go ahead and split this into 10 equal parts. So after the changes, the following represents the dollar amount of her investments. So 2/10 times n, which is the 20% of her investments, increased 5%, so that's times 1 5/100, plus 30% of her investments, which is represented by 0.3 times n. Well, they decreased by 5%, which means that they only increased by 95%. So that is 95/100, and then plus 50% of her investments, which is represented by 5/10 times n, increased 3%. So that's being represented by 1 3/100. So when we simplify that, we get 21/100 times n plus 285 thousandths times n plus 515 thousandths times n, which when we add all those up, we get 1 1/100 times n. So if we show this as a tape diagram, we have two of those 10 boxes, and then showing that it's a 5% increase. So that's the little sliver here. Then we have 30%, and then we're taking off 3 times 500, so that's this red area. And then we have the other 5 blocks, or 50%, and then it's 50% times 3%, which was an increase. So since 1 100th equals 101%, Mrs. McElroy's total investments increased by 1%. So how is an increase of 5% denoted in the equation? Well, the result of 5% increase is that the whole, which is 100%, which is equal to 1, plus another 5%, which is 5/100. And so 1 plus 5/100 is 1 5/100, which is multiplied by n, and Mrs. McElroy's original investment. So how else can the increase of 5% be written in the equation? Well, it can be written as a sum of the original amount and the original amount multiplied by 5/100ths. So why is a 5% decrease denoted as 95/100ths and an increase of 5% denoted as 1 500ths? Well, the decrease is 5% less than 100%, so 100% minus 5% is 95%. In decimal form, that would be 95/100ths. An increase is 5% more than 100%, so the decimal form is 105 or 105/100ths, or 1 500ths. Right, go ahead and try to do exercise 4. If you need help, continue the video to help you get started, and then check your answers at the end. So, based on the problem, let X represent the expected number of attendees on the first night and Y represent the number of expected on the second night. So we have 6,000 attendees. That's going to represent our whole. And the first night, they're expecting a 20% increase of 6,000. So that means 6,000 would be an expected number of attendees times 20% more. And that's going to equal 6,000 attendees. So 1 20/100ths is 1 2/10 times X times or equals 6,000. So therefore X is equal to 5,000. And 6,000 minus 5,000 is 1,000. So the first night attended by 1,000 people more than expected. So the second night is Y equals 20% times Y, or Y minus 20% times Y is equal to 6,000. So that means that they're expecting 80% of the 6,000, because 1 minus 2/10 is 8/10. So when you divide by 8/10, you get Y is 7,500. And the difference between 7,500 and 6,000 is 1,500. So the second night was attended by 1,500 people less than expected. So now if you take those two numbers, the 5,000 and the 7,500, you get a total of 12,500. So now we know the total amount of people that were expected was 12,500 people for both nights. So now if we take 1,500, which was the difference of the first night, and 1,000, or I'm sorry, the difference of the second night minus the difference of the first night, that is a total of 500 people. And 500 people divided by the 12,500, and then multiplied that by 100% is 4%. So the concert missed its expected attendance by 4%. All right, let's wrap this up. So what is the importance of defining the variable for percent population problems? Well, we solve for and set up expressions and equations around the variable. The variable gives us a reference of what the whole, 100%, is to help us figure out the parts or percents that are unknown. So how do tape diagrams help to solve for percent population problems? Well, it is a visual or a manipulative, which helps us understand the problem and set up an equation. Coupled with the 100% bar, it tells us whether or not our answers are reasonable. Give examples of equivalent expressions from this lesson and explain how they reveal different information about the situation. Well, your answers may vary, but for example, in exercise 3, the first night's attendance is expressed as X plus 2/10 times X. This expression shows that there are 20% more attendees than expected. The equivalent expression would then be 1 2/10 times X. All right, we'll see you in class.